Hi guys, we're going to talk about inheritance today. So inheritance is a really good way for you to be able to quickly do some programming. So if you're writing a game or if you're doing something that encompasses a lot of different classes, inheritance is a really important thing to know about because it's going to make your program writing so much easier and so much more efficient. So if you're with inheritance, you could think about it as a program or software reuse. That's really what inheritance is all about. So let's take a look. So this is your very, very basic inheritance kind of idea. Okay? So let's say you're making a game and you have a class named Dude. Dude has a few fields or instance variables called string name, int HP, hit points, int MP equals 0. Okay, we've got all those going on. And what we want to do is we want to have a few methods in here. So one of them is void, and it's called sayName. And all that method does is just print out the name. So the name of the dude. And then public void punch face. That would be, well, I think that kind of speaks for itself, okay? What are we punching in the face? Another dude named Target. And what happens then is Target loses some hit points, namely 10 for every single punch in the proverbial face. Okay? That's public class Dude. That's what Dude does. It's got two methods, sayName and punch face. Now let's say that I want to create a wizard in my game too. And then I'm thinking, okay, wizard's gonna pretty much be what Dude is. So then I'm like, I gotta copy and paste the whole thing, all of Dude's stuff. Well, that doesn't really sound like my idea of a fun time, copying and pasting. So no. But wait, a wizard does and has everything that a dude does and has. So is there some sort of magical shortcut? Yes. You don't have to copy and paste. So to create a wizard, what we're going to do is think, okay, we're going to buy inheritance. We're going to inherit everything Dude does by making wizard a subclass of Dude. Okay? You could think of wizard as a child of the Dude class. Dude would be the parent, wizard would be the child. That's actually how we describe the relationship. We think of it as is a relationship. Namely, every wizard is a dude. Okay, so public class wizard, notice the keyword that we're using here. The keyword is extends. So public class wizard extends Dude. If I leave this class blank the way it is right now, wizard will have all of the stuff that Dude has. All the constructors, all the instance variables, all of the methods, provided all of those methods and instance variables or fields and stuff are all public. Okay? So wizard can use everything that Dude has except for the private fields and methods. A field is another way of saying variable. So everything, so this stuff that we had in there, that's in there now. Wizard can do everything that Dude can do, namely all of the methods that we had, like punching, in the proverbial face. You can use a wizard like a Dude too. So I can say dude1 dot punch face wizard1 if the Dude punches the wizard. Hey, that's cool. That's part of my game. Adds a little twist. Okay, we can even say, okay, well, we wanted wizard to like take on all the stuff that Dude has, but I actually want to change it a little. I want to augment it a little. So I'm going to extend Dude, but now I'm also going to say, hey, I want to let the wizard do something that a Dude can't do, which is like spells, okay? So I'm going to cast some spells, and I can do that and then write all the cool stuff below that's going to make that happen. And that would be really nifty. So hopefully you're starting to see the power of inheritance. Okay, and you can even inherit from a class that's already been inherited from. So let's say that I wanted a Grand Wizard. Well, a Grand Wizard is going to have a lot of the same code that Wizard has. But it's also going to be able to say its name. So Grand Wizard plus whatever the name is. Well, that's pretty cool. Then I could say Grand Wizard 1.name equals flash, and yup, all that stuff can happen. Cool. So how does Java do all that? So what Java does when it sees grand wizard 1 dot punch face of dude 1, what does it do? It looks for punch face first off in the grand wizard class, because grand wizard 1 is an object of the grand wizard class. And then it looks there and says, ha, it's not there. So then it says, huh, well, is grand wizard like a child of anything? Does it have a parent? And it says, okay, look for punch face in the wizard class. Shoot, it's still not there. So now what? Does wizard have a parent? Is wizard the child of something else? Yes, look for punch face. Punch face in the dude class. Oh wait, found it. And then it's going to call punch face. And it's going to do what punch face told it to do, which is deduct hit points from dude 1. Sorry, dude 1. It's rough. Okay, so how does Java do that part 2? What Java does when it sees dude grand wizard 1 dot say name. We've seen this dude thing before, and what it allows us to do is take grand wizard and casts it into a dude. So it casts a dude to tell Java to start looking in dude for what to do next. So this say name method belongs to dude, and it's a way for us to tell Java, hey, grand wizard 1, I'm going to cast it into a dude, and I want you to do say name from the dude class. Then it's going to say, okay, found it, I'm going to call say name. Okay, so to give you an overview of all the stuff we just did here, we started out with dude. This was the parent class. And then we have a number of children that come off of dude, so that extend dude. Wizard extends dude. That's the keyword extends. So wizard extends dude, thief extends dude, elf extends dude. What does that mean? It means that these are all children or subclasses of dude. And you'll also hear that wizard and thief and elf are all subclasses of dude. So you're all going to see the extends keyword in there, extends dude. And the relationship between these two, we call these siblings. Siblings. So wizard and thief and elf are all siblings because they share the same parent, namely the class dude. Okay? And remember our grand wizard that we created? That was actually a subclass of wizard, and wizard is already a subclass of dude. So our grand wizard has a parent and, I don't know, a grandparent, if you will, called dude. That's the relationship. We call this all class hierarchy. That's what you're going to see. And remember the word class, okay, the word class actually comes from the idea of classification. So if you're familiar with anything in biology, which I will be the first to say I'm not as much, but the idea of classification is that you could take objects and put them into certain categories. You can only inherit from one class in Java, which is one of the reasons why interfaces are a thing. Okay? Interfaces give us the power to be able to do more than just inherit from one thing, because we can implement as many interfaces as we want. But we can only extend from one class. So this here, you've got dude, thief and elf are the children of the parent class dude. And this guy right here is a bad elf. Okay? He's a bad elf because you cannot inherit from elf and thief. That's not something you can do in Java. You can only inherit from one class. One of the reasons is, what if thief and elf both implement a sneak up method? And if they implement it differently, which one was Java know how to use? Java doesn't know, it gets confused. It's too much, it can't handle it. No good. Okay, the summary of inheritance here is we use the extend notation for is a kind of relationship. Okay, when we were talking about, what are those things called? Not implement, but yeah, implements. When we were talking about implements, we were talking about how it's able to, right? Able to, that was an interface. Is a is inheritance. So that's describing the relationship between various classes. Okay, and we say that A is a subclass or a child of B. Either one of those, subclass or child. A has all of the fields, these are instance variables, all of the fields, all of the methods that B has. And A can add its own fields and methods. If you want to do that, you can. You can also override them. A can only have one parent. Sorry, you can't have two parents in Java. A can replace a parent's method by re-implementing it. So we also call that overriding. So keep that in mind, overriding. Okay, a mammal is an animal. A dog is a mammal. Old Yeller is a dog. Do you see the relationship in terms of classification? Old Yeller is a dog and a dog is a mammal, so Old Yeller is a mammal. A bird is an animal. A chicken is a bird. Foghorn Leghorn, check that guy out. He is a chicken. He doesn't think he is, but that's his category, that's his classification. So all of this is about the idea of is A, which is inheritance, where X is an extension of Y. Okay, here we have class A. We have a private int X, and in class A we have this constructor that's setting X equal to 8. And there's a toString method. So if I have a different class out there and I say, hey, class B extends A, and now I have a main method out there somewhere, and it's saying, hey, A equals 1, so we've instantiated a new A called 1, and we do a println on 1, what does that call? That calls the toString, and it returns 8 because the constructor sets it to 8. Now if I create a new B right here, what is B? B is over here. Here's B. It extends A. That means it has all of the same fields or instance variables and methods that A has. So if you call the println on this new instance you've called 1, new object of the B class, it still calls the toString. It looks for the toString of the parent, and it will print the same thing, 8. Okay, the object class is the one true superclass. So object does not extend any other class. All classes extend object. So this is like the exception to the rule. I told you earlier that Java you cannot extend 2 different classes. Well, that's pseudo true because all classes extend object, okay? Everything is an object. String is an object, etc. Because all classes are subclasses of the object, the super or the mother class, all Java classes start with at least the methods from object. What are some of the methods from object that you'll see? You'll see an equals. Dot equals is in every single class. It's there by implication if you don't define it. You'll see the toString. This is why if you call an object by its reference variable, automatically Java defaults to toString because that's the object toString that it calls. Hashcode, clone, and more. Okay, these 3, the top 3 are on the AP exam. We'll discuss hashcode some more later. So a string is an object, which means that every string has string methods from the Java library. Okay, dot substring, dot equals, etc., string variables, but it also has all of the object methods and variables as well, because a string is an object. And sometimes it overrides what it knows to be true about object methods. So we talked previously here just a second ago about how every object has a dot equals. Well, string also has a dot equals. It's just more specific in its method about what dot equals is in string. Because what does it look for? It looks to determine whether or not every character in that string matches every other character in every other string that it's comparing it with. So it just overrides the dot equals that is up here and is specific about what it means to equal. So more clarity, and it overrides it. You can do the same thing when you inherit, and you use inheritance using extends. you can override any of the methods that you're inheriting from your mother or parent class however you want. Okay. This is just to give you an example of what it may look like to extend or inherit. So here we have a public class which, and which extends monster, which means which has all of the instance variables. Here are the instance variables. You see a string called my name. There's an instance variable. You've got a constructor that sets my name to monster right there. You've got a public monster that takes in a string name, that's another constructor, and you have a toString which returns the monster's name, which has all that stuff in it. Why? Because of the word extends below. Public, okay. You can declare methods to be public or private or protected. And up to this point, we've kind of made all of our methods public. So I want to talk a little bit more about that and make sure you understand the difference with access. Okay, if you decide to declare any of your methods private, and then you inherit from that class by using the extends keyword, if any of those methods are private, you cannot access them, even though you inherit it in the child. So the child still inherits everything from the parent, but if it's private, it can't access it. So you want to make things public in terms of methods. Here is a more clarity. If you want to protect it, you can also protect a class, and when you protect it, you allow people to access it in the child class. And in fact, from any class that is in the same package. So this is why it's also commonly referred to anything that's protected with that keyword in it. Instead of public class, you would say protected class, whatever. All of that is also considered to be called package public, which means it's public to any other file in the package. Anything that's private can only be accessed within that class. We've talked about that before. If you make something private, keep in mind that the moment that you do, the children, any children that you have from that parent class can't inherit the stuff, or at least can't access it. Okay, what's considered to be good design in your programs is to hide information. So information hiding is a big part. It's demonstrated with inheritance in that superclass code is written, tested, and then tucked away. What's superclass code? That's parent code. Okay, so when you see the word super, it's just calling the parent class. Subclasses can be written using the superclass methods with no real concern for the implementation details in the superclass methods. So we're not, this is the cool thing about it, is I can define what it means, you know, to climb, for a monkey to climb a tree. I can define it somewhere else. I can call that method whenever I want, and if I say, hey, blah, 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 dot climb tree, and whatever this class is that I'm working on, if it's related, if it's a child or a sibling even of a class that does that, it can call upon the method and know what it does without me looking at it. This is really important. So I hope you get this. I hope you're seeing this. This refers to the object class that you're working on. So if I want to say like this.toString, you've seen me use this in some constructors before. It's very often used in constructors. This.toString calls the toString of which class? Of this one, of the one that I'm working in. See, if I name it, let's say that I create an object of the class called Bob. If I say Bob.toString, Java doesn't like that. I have to be more general, right? Because you can have another object called Bill. And if I put Bob.toString in my code, when Bill shows up, it doesn't know what the heck to do. So this is really useful, and it's a shortcut. And all it does is just call to the instance of this class. You can use this as a constructor, and then you'll see a constructor call. Okay, so technically this has been in everything you've been using by implication, and I can show you that later. Here's an example of how this is useful. Here I have a class monster and a private string called my name. I have a constructor, two in fact. One constructor takes in a parameter called name, which is a string. The other constructor here is the default constructor. Notice the default constructor doesn't have a parameter, right? So what I've done here is I've just said, hey, if there's no parameter, then I want you to set this equal to monster. So I want you to pass monster in. So what it really is it kind of becomes a reference and says, hey, what I want you to do from there is take the monster right there and throw it in right there into that constructor. So this refers to the class itself and says, take that monster and take monster, that string, and throw it right in here where it says name. So it will take my name and set it equal to monster. Okay, whenever you're using the word super, it's a key reserved word in Java. It refers to the parent class. So you can call super.toString, and that calls the toString of the parent class. So if you're working in the child class, you can use the word super to refer to the parent and go straight to the parent. You cannot say super.super. Like if you have some class that's a grandchild of another class, you can't call super.super. That's not allowed. Okay. Skeleton class. This class extends monster. Here, super call is always, whenever you're making the super call, you have to make it on the first line of any subclass. So as soon as you start declaring what the method is, you want to throw it in there. And remember, whenever you're using the word super, you're referring to the parent. So in this case, we have skeleton. Skeleton is a child of which class? Of the monster class. So when I'm saying super here, I'm referring to the word monster. I'm referring to the class monster, and I'm throwing name and saying, hey, name, throw that into the constructor of monster. Okay. Polymorphism is the ability of a general thing to behave like other specific things. Example, here we have an object called X. Okay, X has been declared as an object. So that's the data type. But I'm setting it equal to something with double quotes. So doesn't that indicate that comp_sci is a string? Why is it that if I say system.out.println of X, why will it work? Why is it okay to have an object referring to a string? Okay, the reason for that is because every string is an object. So I'm allowed to refer to it by the parent. I'm allowed to do that. That's okay. Now I'm going to take it even a next step and say, now I'm taking this object X, I'm still saying it equal to comp_sci, which is a string, and now I'm calling a println of not just X, but X.toString. Why is it okay to call the toString method on the reference variable X, which is an object? It's okay for me to call the toString method because the toString method is a method that is also found in object. Remember that every single class out there is a child of the mother class called object. An object has a toString. Now, why is it not okay here for me to take X, which is an object, I'm passing in comp_sci as a string. Why is it not okay for me to use the .length method here? The reason that's not okay is because it's looking and acting and trying to find a .length method of object. But what do we know about that? We know that there isn't a length method of object because objects don't have length. What has a length? String does. So what's the solution? If you want to call .length of comp_sci, which you have identified as an object, what you have to do is cast it into a string.